Hi everyone, myself Jyoti Prasad from RMD Engineering College. Now we are going to discuss about non-inverting operational amplifier. Earlier video we have discussed about inverting amplifier. Uh, Earlier we have discussed two types of configurations will be there: open loop configuration, closed loop configuration. And in closed loop configuration we are going to make it as an amplifier. So most probably we will have inverting amplifier, non-inverting amplifier, and differential amplifier. Three types of operations we are going to do here. Like I said in earlier video, inverting amplifier will have an open loop gain of minus RF by Rin. Now in this video we are going to check about the what is the open loop gain, how the output will come for a non-inverting amplifier. We know what non-inverting amplifier will have the major input to non-inverting terminal, nothing but plus terminal. Non-inverting means positive terminal. So obviously the inverting terminal will be towards ground. So see here, if we see this block diagram here, this in the circuit the negative terminal nothing but inverting terminal we made ground through input resistance R in with the current limiting resistor. So through this one we are going to ground this resistor R in. And obviously our like regular setup we have the RF feedback resistor in the loop, feedback resistor in the loop. So it makes from the output to input current flow. So RF. So if we see here, input we are going to give through positive terminal, non-inverting terminal. So but here the resistive network which we have, so normally we will take RF or in combination. Few people in few textbooks they will take R1 R2. So we can take as RF Rin. For example, with respect to circuits, if I take R1 R2 two resistors, so it seems exactly like this voltage resistive divider network. So V1 we are giving input, R1 present at this intermediate point between these two resistors we are going to take output V2, uh, and the R2 resistor going to get done for ground. So we can also redraw the circuit in such a way that in the right top corner, V1 is the input voltage given to R1, and after R1 a resistor R2 made to ground, and after this point we are going to take the output voltage V2. So using resist voltage divider bias, okay, we are going to calculate this amount of resistance, opposite resistance by total resistance R1 plus R2. Here in this case R2 by R1 plus R2 into input is nothing but V1 will come. So let us apply the same thing for our non-inverting amplifier. So we know earlier input voltage V in equal to R in into I in. The current flow through resistor R in is I in. So if you multiply these two things, we will get the which is equal to V input voltage. So if you rewrite this one, I in is nothing but V in by R in. So we are applying the same voltage divider rule for our network, which is in the non-inverting amplifier. So see here, the voltage divider rule. Input voltage is V in equal to, so V out by V out. That is nothing but the opposite side. What is voltage V out by V out into opposite resistance R in by R in plus RF. So we are such a way that see if we want the reference is V out is equal to the second side voltage V out is equal to V in. So V in into R2 by R1 plus R2. From this one we are going to take like this. If we separate the voltages at one side, ratio of voltages V naught by V in, that will called as a gain. Then V out by V in. For we can rewrite that one as a V in by V out also, no issues. So you see here, R in by R in plus RF by RF. So we, if we rewrite this equation, uh, the LCM can be done 1 plus RF by Rin. So we know the closed loop gain for this op amp is, closed loop gain for this one is AOL, nothing but output voltage by input voltage. So V out by V in is termed as ACL, closed loop gain. How much means 1 plus RF by Rin. Closed loop gain is equal to V output by V input, 1 plus RF by Rin. So now what is the output? We can substitute this one in the this equation, V output equation. V in into minus earlier equation. Earlier equation is nothing but inverting, that is the output. Okay, here this one This one we are going to write like 1 plus rf by r in, 1 plus rf by r in into v in. So for non-inverting case we want to write like this. For inverting case, minus rf by r in into v in, we know earlier. So, for example, for a non-inverting amplifier, like we have discussed now, if I give a 2 volts peak to peak input, 2 volts, see 1 volt at positive, 1 volt at negative, 2 volts peak to peak input. So, depends upon the RF R in combination, the closed loop gain will come 1 plus RF by R in. So, depend upon that amount, it will get amplified. So, definitely it will be more than the input. So here if we see the output, so we don't have any sign change. Okay, so v naught is equal to my 1 plus rf by r in into v in. So get amplified and no sign change, the output looks like this. So if you want to compare with the earlier non-inverting, inverting, so see the first circuit I have shown is which one, guess it. The first circuit we have shown is not inverting amplifier. So as we have given input to inverting amplifier, the output is got 180 degrees phase shift. Now whatever we discussed recently is non-inverting amplifier. What we have given input to positive positive terminal, so which will get the output as a without phase shift, without phase shift. For example, you will have a doubt that, so if at all I have given the two inputs v1 v2, v1 v2, some quantities, one, what will be the output? We have seen in the first slide, the square waveform will come when v1 is greater than v2, then minus vch. V1 is nothing but here negative terminal. When negative terminal dominates positive terminal voltage, so v1 is greater than v2 means minus v saturation will come. When v2 is greater than v1, plus v saturation will come, such a way that we will get a square waveform. Thank you.